Hello everyone. On this video, we will explain on application of derivative. So this is one of the example. The Metal Can Company has an order to make cylindrical cans with a volume of 250 cubic centimeters. What should be the dimension of the cans in order to use the least amount of metal in their production? We are asked to find the dimension of the cans. It is traditional to take as the dimension of a cylinder the head h and the radius of the base r as in figure 1. Imagine removing the circular top, the bottom, and then cutting vertically and flattening out the hollow cylinder to get a rectangle as shown in figure 1. Our objective function is the total surface area S of the can. The area of each circle is pi r square, while the area of the rectangle piece is 2 pi r h. Thus, our objective function is S equal to 2 pi r square plus with 2 pi r h. As usual, there is a constraint. The volume must be exactly 250 cubic centimeters. The formula for the volume of a cylinder is V equal to pi r square h. So, pi r square h equal to 250. It is easiest to solve this constraint for h in terms of r. H is equal to 250 divided by pi r square. Substitute in the objective function, we get S equal to 2 pi r square plus with 2 pi r 250 divided by pi r square and equal to 2 pi r square plus with 500 over r. Now, r cannot be negative or 0, but it can become very large. So, we take the domain of SR to be 0 until positive infinity. So, our mathematical problem is as follows. Minimize SR equal to 2 pi r square plus with 500 over r, and our subject to r is more than 0. Now we calculate S prime r equal to 4 pi r minus with 500 over r square. To find stationary points, we set this equal to 0 and solve it. 4 pi r minus with 500 over r square equal to 0, and then 4 pi r equal to 500 over r square, and then we get 4 pi r cube equal to 500, and we solve it and we get r cube equal to 125 over pi. So we get r equal to cube root 125 over pi, and we simplify it until we get 5 over cube root pi, and the answer is equivalent to 3.41. So to calculate h equal to 250 divided by pi r square, and we get the answer is equivalent to 6.83. Thus, the can that used the least amount of metal has a head of approximately 6.83 cm and a radius of approximately 3.41 cm.